In this video, we are going to solve a few questions involving normal distribution. The first example, the diameter of the ball bearing produced by a machine in a factory are normally distributed with a mean of 10 mm and standard deviation of 0.1 mm. So X is diameter of ball bearing. Okay, so mean is 10, standard deviation is 0.1. Okay, this is normal distribution, so Z equals to X minus mu over sigma. Okay, question A. If a ball bearing is chosen at random, find the probability, so P. Diameter is less, so diameter just now X less than 9.8. Okay, this one is not standard yet, so you have to make it standard by using the formula of Z score. So Z less than 9.8 minus 10 over 0.1. So then we get Z less than negative 2. Okay, so then we draw the normal graph. So negative 2 is at the left, so less than, so at the left as well. So you have to reflect to get the upper tail. So you reflect, you get here 2. So now this is upper tail, so you can express like this, Q2. From the previous lesson, you already knew how to read the table of normal distribution. Okay, so Q2 right here 0.0228. So 0.0228. Okay, so the next question B. If the machine produces 1000 ball bearings in a certain day, find the number of ball bearings with diameter greater than 10.15 mm. Okay, to find the ball bearing, you have to find the probability first. So you have to find the probability diameter greater than, so X more than 10.15. Okay, so make it standard. So Z more than 10.15 minus 10 over 0.1. Okay, so here we get Z more than 1.5. Okay, so we draw the normal graph. Okay, more than 1.5 is at the right. Okay, more than right here, so exactly upper tail. So you refer the table 1.5. Okay, 1.5, 0.0668. So 0.0668. Okay, but now the question asks you to find the number of ball bearing. Okay, so by using the formula of probability of event A equals to number of event A over number of sample space, you can substitute the value of probability, which is 0.0668. Okay, number of ball bearing you are going to find, and number of sample space is 1000. Okay, so therefore number of ball bearing is 0.0668 times 1000 equals to 66.8. Okay, we take 66 because 0.8 is not a complete ball bearing. The next question, find the percentage of ball bearings that have diameter between 9.85 mm and 10.05 mm. Okay, same thing, before you find the percentage, you have to find the probability first. Okay, so C, you have to find the probability diameter between this value. So X between 9.85 and 10.05. Okay, so as usual, you have to make it standard. So P 9.85 minus 10 over 0.1 is Z less than 10.05 minus 10 over 0.1. Then we get here P negative 1.5 and 0.5. Okay, equals to, okay, so then you have to draw the normal graph. Negative 1.5, negative, left. Okay, 0.5 positive, right, so then between, so right here. Okay, to find the shaded region is 1 minus Q 1.5 minus Q 0.5. Okay, so then from the table you get 1.5 is 0.0668, 0.5 is 0.3085, 0.3085. Okay, so therefore 1 minus these two values is 0.6247. Okay, so therefore the percentage is 0.6247 times 100%, which is 62.47%. Next question. The mass of student in a school has a normal distribution. Okay, so X is mass. Okay, mean mu is 54. Standard deviation is 12 kg. Okay, find the mass of the student which give a standard score of 0.5. Okay, here standard score is Z equals to X minus mu over sigma. Okay, Z is 0.5. X is, we are going to find X. Okay, mu is 54 and standard deviation is 12. Okay, so then you get X equals to 0.5 times 12 plus 54. So X equals to 60. So the next question, the percentage of student with mass greater than 48. Okay, so probability mass more than, so more than 48. So you have to make it standard. So PZ more than 48 minus 54 over 12. Okay, this one equals to Z more than negative 0.5. Okay, we draw the normal graph. Okay, negative 0.5 at the left side. Okay, 0.5. So more than is right here. Okay, so this one we use 1 minus Q 0.5. Okay, Q 0.5 is 0.5. Okay, 0.3085. 0.3085. Then we get 0.6915. Okay, to find the percentage is 0.6915 times 100% equals to 69.15%. Next question, the mass of the workers in a factory is normally distributed with a mean of 67.86 and a variance of 42.25. Okay, so now mass is X. X is mass. Okay, so then mean is 67.86 and variance is 42.25. Now to find the standard deviation is square root of variance. Square root 42.25, we get 6.5. 200 of the workers in the factory weigh between 50 kilograms and 70 kilograms. Find the total number of workers in the factory. Okay, now before find the total number of workers, you have to find the probability. So probability workers between 50 kilograms and 70 kilograms. Okay, so you have to make it standard. 50 minus 67.86 over 6.5. Then this one Z. Okay, less than 70 minus 67.86 over 6.5. Okay, so then we get here negative 2.748. This one 0.329. Okay, so then we draw the normal graph. Negative at the left side, positive right side. Okay, between is right here. Okay, so to find this probability is 1 minus Q 0.329 minus Q 2.748. Okay, by using the table or calculator, you get this value of probability. Okay, this one 0.3711 minus 0.00299. Okay, the probability is 0.6259. Okay, by using the formula of probability of event A equals to number of event A over number of sample space. For this situation, we already have the probability 0.6259. Okay, number of workers with weight between 50 and 70 is 200. Now we are going to find number of sample space. Okay, so number of sample space is 200 over 0.6259 equals to 319.5398. Number of workers is integer, so we write 3.9. Next question, a survey on body mass is done on a group of students. The mass of a student has a normal distribution with a mean of 50 kg and a standard deviation of 15 kg. Okay, so then X is mass. Mean is 50 and standard deviation is 15. Okay, A. If a student is chosen at random, calculate the probability that his mass is less than 41 kilograms. Okay, so probability mass X less than 41. So first of all, you have to make it standard. So P Z less than 41 minus mu over sigma 15 equals to PZ less than negative 0.6. Then we draw the normal graph. Okay, negative 0.6 is at the left, less than at the left. Okay, so then this one you have to reflect to get the upper tail. Okay, so now to find this probability is Q 0.6. Okay, then you can find from the table 0.2743. Okay, the next question, given that 12% of the students have a mass of more than m kg. So mass more than m, X more than m. So 12% actually the probability. Okay, probability is 12 over 100, which is 0.12. So you have to make it standard. PZ more than m minus 50 over 15 equals to 0.12. Then you draw the normal graph. Okay, more than is from the right. Okay, 0.12 is the probability. So less than 0.5. So somewhere here. Okay, so then from the table you refer the probability is in the table. Okay, so 0.12, the nearest one is 0.1210. So you have to minus 10. So the z-score is 1.175. Okay, so m minus 50 over 15 equals to 1.175. So then you can find m. Okay, equals to 67.625. Okay, next question. The mass of watermelons produced from an orchard follows a normal distribution with a mean of 3.2 kg and a standard deviation of 0.5 kg. Okay, so now X is mass of watermelon. Mu is 3.2. Okay, and standard deviation 0.5. Okay, find the probability that a watermelon chosen randomly from the orchard has a mass of not more than 4.0 kg. So probability mass X not more, less or equals than 4.0. So you have to make it standard. 4.0 minus 3.2 over 0.5. Okay, here we get Z less than 1.6. Okay, so then we draw the normal graph. 1.6 here, less than here. Okay, so to get the upper tail is 1 minus Q 1.6, which is 1 minus 0.0548 equals to 0.9452. Okay, the next question B. Okay, find the value of M if 60% of the watermelon from the orchard has a mass of more than n kg. So mass X more than n kg. Probability P, 60% means 0.6. Okay, so you have to make it standard. Z more than M minus 3.2 over 0.5 equals to 0.6. Okay, so then we draw the normal graph. Okay, more than from the right. 0.6 is more than 0.5. So more to the left. Okay, so this is 0.6. So this one, the opposite probability is 0.4. Okay, so then you have to refer 0.4 as a probability in the table. 0.4 here. Okay, 0.4 nearest 0.4 is 0.4013. So you have to minus 13. Nearest 13 is 12. Okay, so 1.253. Okay, 0.2, sorry, 0.253. Okay, so but the position is at the left. Okay, so the value is negative. Okay, so now you get the value of M equals to 3.0735. Okay, the next question. The cumulative grade point average CGPA of the final year student in a university follows a normal distribution. So X is CGPA. Okay, mean is 2.6 and standard deviation 0.25. Okay, A. If one student is randomly selected, find the probability that CGPA of the student is more than 3. Okay, so probability CGPA X more than 3.0. Okay, so this one you have to make it standard. Z more than 3.0 minus 2.6 over 0.25. Okay, here we get Z more than 1.6. Okay, so you draw the normal graph. Okay, 1.6 positive, so at the right. Okay, this one upper tail, so 1.6. So you just by using calculator or table, you get the probability 0.0548. Okay, B. A degree will be given to the final year students who obtain CGPA more than K. Okay, so X more than K. Okay, if 89.5% of the student manage to get a degree, find the value of K. So the probability is 89.5 over 100, which is 0.895. Okay, so then you have to make it standard. Z more than K minus 2.6 over 0.25 equals to 0.895. Okay, so then we draw the normal graph. Okay, so now this is the probability more than from the right. Okay, 0.895 is more than 0.5, so more to the left. Okay, so here, so you have to find this probability, which is 1 minus 0.895, 0.105. Okay, so we refer the probability in the table. Okay, 0.105. Okay, or nearest, so the nearest one is 0.1056, so you have to minus 6, so the Z score is 1.253. Okay, so 1.253. Okay, but the position is at the left, so negative. Okay, so K minus 2.6 over 0.25 equals to negative 1.253. So K equals to 2.2868.